Hi and welcome to this talk about the Wolfram Hydraulic library. My name is Johan Rhodin. The Wolfram Hydraulic library is developed by Wolfram MathCore. It's available on the Wolfram SystemModeler library store and you can download it there directly. The Wolfram Hydraulic library contains a large collection of ready-to-use and reusable hydraulic components such as pumps, valves, motors and different types of media that can be used to create large-scale hierarchical models that don't have to be limited to the hydraulic domain. It can also be connected to components from other domains in the Modelica standard library or your custom components. Some of the example industries where the library can be used include the automotive industry, construction and power systems. When you open the hydraulic library, you'll see a number of different components available, such as cylinders, pumps, motors, valves, different media, and also a large number of examples from different applications. There's also sensors available that can sense mass flow, pressure, and also use that as an output that can be used in other applications. One example where the Wolfram Hydraulic library is practically applicable is when modeling failure scenarios, for example in avionics. Take the flap system in the Cessna 441 Conquest II airplane as an example. The flaps are located on the trailing edge of the wings, where they can take on different angular positions depending on which flight characteristics are wanted. That in turn depends on if the plane is in the landing or takeoff phase, in mid-air or approaching landing. The flap system as a whole is controlled by electrical signals, but it is hydraulically actuated. So using the hydraulic library together with SystemModeler's modeling capabilities in the electrical and mechanical domain, it is possible to model the entire flap system and incorporate different failure scenarios in the subsystems. For example, in the hydraulic system, what happens to the flaps and to the plane if a hydraulic valve starts to malfunction? Let's take a closer look at the model in Model Center. The model of the flap system consists of 6 subsystems, seen here in the diagram view. We have the pilot, who manually chooses the flap position using a flap selector switch on the instrument panel. The electrical system, the hydraulic power system, a power plant, the landing gear subsystem, and the flap subsystem. Of these 6 models, the Wolfram Hydraulic library has been used to model 2 of them, the hydraulic power system and the flap subsystem. Let's take a closer look at them. This diagram view shows the hydraulic power subsystem, which is designed to provide pressurized fluid to the flaps and landing gears. The white and light blue boxes are hydraulic connectors. The dark blue ones are electrical connectors, and the gray circles are rotational mechanical connectors. By using and building on the ready-to-use components in the hydraulic library, all the hydraulic components have built-in parameters that control their health. For example, leaking pipe, healthy pipe, and pipe with an obstruction. The flap subsystem is connected to the pilot, the electrical system, and the hydraulic power system in the main model. Based on the signals from the electrical systems, the valve will open, close, and supply fluid to the hydraulic cylinder. The cylinder will push the flaps back and forth. This slide shows the simulation results of a nominal scenario. In other words, when the system works as it should and there are no malfunctioning components. We simulate the model and look at the voltage from the pilot, the pressure in the system, and the angle wanted from the pilot and what the actual angle is. As we can see, in this scenario the commanded and the real flap angle match except when the flaps are moving to adjust to a new flap position. Let's investigate what happens if we insert a failure in the flap system. The failure in this case is a pin short in the up solenoid in the flap control valve. This means that when the pilot tries to command the flaps down, the short circuit to ground is no longer isolated from the circuit breaker. In this scenario, the flaps are initially in the up position, as we can see in the simulation plots here. The pilot issues a series of commands: takeoff, up, approach, landing, and up. The pilot didn't test to move the flaps up and down before taking off, which otherwise would have revealed the failure, and so it's not tried until the plane is in midair. As you can see, the system behaves okay until the pilot tries to move the flaps back up. The circuit breaker has tripped and the pilot loses control over the flaps, which remain in the takeoff position. Safety procedures can also be modeled and tested in the SystemModeler. A possible safety procedure would be to move the flap selector switch to landing and then reset the circuit breaker. This would allow the pilot to move the flaps to the landing position, since the short circuit would be isolated from the circuit breaker when it is reset. If the pilot would not follow this instruction, the aircraft would need a longer runway than before, which could be problematic. So in conclusion, the Wolfram Hydraulic library is available from the library store. It contains an extensive collection of components which are well integrated with other components in SystemModeler, and we have demonstrated the functionality in a practical example.